On Oct 29, 3I Atlas slips behind the sun, vanishing from Earth's telescopes for 6 weeks. The 20-kilometer, 33-billion-ton interstellar object shows no non-gravitational acceleration. While NASA calls it a comet, some, e.g. Avi Loeb, suspect a hidden maneuver that could trap it in our solar system. If you're into mysteries like this, tap like so the algorithm knows to show you more deep space stories. When October 29th arrives, the geometry of the solar system will turn against us. Earth, the Sun, and 3I Atlas will align in a straight line, leaving our planet on the wrong side of the glare. For nearly 6 weeks, the comet will be invisible, unreachable by ground-based telescopes, or even space observatories like Hubble and JWST, which cannot risk pointing near the Sun. Every instrument will go dark. Astrometric tracking, brightness measurements, and spectral data, all interrupted. Only a few solar probes might glimpse faint hints of its presence, but their sensors were built for solar storms, not mysterious cosmic visitors. For most scientists, this blackout is maddening, because if Atlas performs any sort of orbital maneuver, natural or engineered, it will happen in total silence, at the very moment we can't observe it. Quick pulse check. Do you think Atlas is natural or engineered? Drop a comment with natural or engineered. The first shock came from the data. Early photometry put 3I Atlas near 20-kilometer cross, almost 10 times bigger than Oumuamua or Borisov. Its bright reflection suggested a massive, coherent body, not shattered debris. Yet the deeper puzzle was its stillness. Despite vigorous CO2 outgassing, over 100 kilo per second, Atlas clung to a purely gravitational path. Comet jets usually act like tiny thrusters, nudging trajectories. Here, after 4,000 precise position measurements, no non-gravitational acceleration appeared. For that to be true, Atlas must be extraordinarily massive, or its outgassing astonishingly symmetric, an arrangement nature rarely achieves. Simulations indicate anything smaller or less dense would have wandered off course. The math offers little comfort. Atlas resists ordinary explanations. In the mathematics of discovery, size should follow probability. Small objects outnumber large ones by thousands to one. So if telescopes can spot a giant interstellar body like Atlas, they should already have found countless smaller ones. But they haven't. Across years of sky surveys, from Pan-STARRS to Atlas to the Vera Rubin Observatory, astronomers have recorded millions of objects, yet only 3 are confirmed as interstellar. So either the universe hides an unseen swarm of faint wanderers, or Atlas is an anomaly, an outlier that breaks the rules. In science, anomalies are where revolutions begin, or where errors are revealed. But as of now, every piece of data reinforces the strangeness, not the mistake. Enjoying the ride? Hit subscribe so you don't miss our December follow-up when Atlas reappears. Trajectory plots of 3I Atlas show something equally unnerving. Instead of cutting through the solar system at a steep interstellar angle, Atlas glides almost perfectly along the ecliptic plane, the same thin disk where all major planets orbit. Only a 5-degree tilt separates its path from ours. That's rare. Statistically, interstellar visitors should arrive from random directions, not precisely aligned with the solar plane. But Atlas's story grows even stranger. Its journey threads near multiple planets in quick succession, brushing past Mars, then Venus, and later Jupiter, a sequence of near flybys so precise that orbital dynamicists call it mission-like. The odds of such an alignment occurring naturally are vanishingly small. Each pass could subtly change its speed, perhaps setting up the conditions for a final maneuver near the Sun. For those open to unconventional ideas, this alignment feels less like coincidence and more like choreography. When the first high-resolution images of 3I Atlas arrived, astronomers were confused. Instead of the classic comet tail trailing behind, the brightest glow appeared on the forward, sunward side, as if the light were coming from its face rather than its wake. Weeks later, the pattern flipped, revealing a normal tail. Some dismissed it as geometry, a trick of viewing angle, but others saw a deeper mystery. Spectral data soon added fuel to the fire. JWST detected an unusual chemical ratio, carbon dioxide outnumbering water vapor 8 to 1. In most comets, water dominates. Here, the chemistry suggested an untouched interstellar composition, or perhaps an entirely different kind of object altogether. Then in late September, observers across the world reported a sudden green flare sweeping through its coma. The emission came from excited carbon molecules, but its timing was off. Too early, too strong. Each layer of data added another contradiction. Atlas was bright where it shouldn't be, quiet when it should roar, and chemically unique among known comets. Tell me in the comments, if Atlas stays, what should we name a new interstellar resident? At perihelion, its closest point to the Sun, 3I Atlas will race through space at nearly 44 kilometers per second. If it changes velocity by even 8 kilometers per second, that's enough to shift it from a fleeting visitor into a permanent resident of our solar system. That moment, that possible maneuver, happens right in the middle of the blackout, when the sun's glare hides everything. No telescope will see it, no probe can watch. Only after December, when Atlas emerges from behind the sun, will astronomers compare its orbit to predictions and see if something changed. If its path bends toward a bound orbit, it means a mysterious force acted on it. If not, it remains what the official record claims: a comet from the stars passing through one last time. NASA's Tom Statler and most mainstream astronomers urge caution. To them, Atlas is strange, yes, but still a comet. Large comets are rare, and their behavior unpredictable. Outgassing patterns, density assumptions, and chemical variations can all create the illusions of anomaly. But Avi Loeb's camp argues the opposite, that too many coincidences have stacked together. The immense mass, the perfect trajectory, the chemical oddities, and now the blinding timing of the solar conjunction. Each feature could be chance. Together, they start to look deliberate. Loeb doesn't claim certainty. He only insists that extraordinary anomalies deserve extraordinary attention. And so, the world waits. The next window opens in early December 2025, when Atlas reappears. Every major observatory will track its orbit, its spin, its brightness, and its chemistry. If it remains unchanged, the natural explanation wins. But if its velocity or trajectory shift even slightly, a new chapter in cosmic history will begin. If you want that update the moment it drops, make sure you're subscribed. For now, 3I Atlas drifts into the sun's shadow and into silence. Whether it's a comet, a cosmic coincidence, or something built for reasons we cannot yet imagine, no one can say. What we know is this: a massive interstellar body is passing through our system, perfectly aligned, perfectly timed, and about to disappear where no eye can follow. When it returns to view, its orbit will tell us everything. Until then, we stand on the edge of discovery, watching the heavens, waiting for Atlas. If this story lit up your curiosity, please like, subscribe, and comment your prediction for December.